Example in Spark is counting words. So let's say that we have word count. So it sounds simple, but it's not that simple. Why is it not that simple? It's not just counting the words, because in this problem we also want the special words. For example, if we have the, is, and spaces, we do not count them as special words. So we have two set of files. One set of files is some text, some big text where we want to count the major topics, the major keywords. Another file would contain words we want to exclude. We already know that we don't want is, the. There are better ways to exclude the is, the, such as tf-idf, but we don't do this. Okay, so the first thing is the spark context.txt file, and in the input to this function, we give it with the file that has all the input text if we have it locally. Then we do a map and we do some cleanup to this file. Because if we have punctuations, etc., we want to remove them. So we use the map function on the RDD. Then we do with a filter, also if we have some blank lines. So we remove the blank lines. Then with the .flat map, we transform each sentence into the words. So if we use map, we transform one thing to the same thing. But when we have flat map, we can actually transform a sentence to a couple of words. So if we have one row for each sentence in the input RDD, and we want in the output RDD one row per word, then you see a sentence can have 10 words. So the output RDD should have 10 lines for the single line of the sentence. And this is where flatmap is used. In flatmap, we just say rdd.flatmap, and then we say, how are we going to split the sentence? Split with a space, and then we are going to get an RDD that contains in each row a word. Then it's also again possible that some of the words would be blank. So we again use rdd.filter to remove these blank words. Anything with the length 0. Then we use again the .rdd.filter, and in the brackets, we filter all the words that are contained in some exclusion list. We have some exclusion list of words, and we exclude all the words to there. Then we can do rdd.map2pair in order to convert these words. Right now we have in the RDD only a list of words, but we want for each word to count how many times it appears and then to take the top 100. So counting in MapReduce, we first map each word to 1, to word, and then some word, Apple 1, Apple 1, Apple 1, MacBook 1. And then we want to reduce it by the word. So we already have rdd.reduce by key. And we give to this function the value of the first word plus the value of the second word. Both words would be the same because we used reduce by key. It knows to do the reduce by a specific key. And because we give it a sum function, it would sum the values. And the values are always 1. So if some word appeared 3 times, it would sum it up 3 times. Then we want to sort by the word that has the most occurrences. So we have sort by key, but sort by key in the rdd.sort by key, but it's not good enough because the key is the words and the values are the numbers. So we do again map2pair. We take the tuple and we replace tuple underscore 2, comma, tuple underscore 1. We just do from tuple to open brackets for declaring tuple, and then for the first argument, we give the second tuple, the second item of the tuple, and for the self, we just switch them in this way with map2pair again on the tuple. Then we can do rdd.sort by key, and because we give it the argument false, it would be in a descending order, and then of course we can do the final thing, which is rdd.take 100 to get the top 100 words. So this was how to get the top or appearing unique, special 100 words from a file.